Hello everyone, welcome back. In this topic, we'll cover load balancer. This is our agenda. We'll have a little bit of pre ELB talk, then we'll start with elastic load balancer, then classic load balancer, demo on classic load balancer, the architecture of ELB components, and finally, we'll conclude part 1 with another demo. What is a load balancer? What does it do? And what are its use cases? Let's say the server is hosting an online retail web page, for example, Amazon.com, and this is the only server or machine hosting this website. And we have users all over the globe. They browse on a normal manner, then Amazon announces big discount on all products. Suddenly, traffic increases in a rapid manner. Unable to handle this load, the server crashes. This is where load balancer could help. You can use multiple servers to host the same application, and you can put load balancer in front of the servers to uniformly distribute traffic among these servers. Load balancer is a device which uniformly distributes network traffic across multiple servers or cluster of servers. If we have the same users as we discussed in the previous slide, but this time instead of one, we have multiple servers hosting the exact same application. In this case, Amazon.com's online page. Instead of getting traffic directly from users over the internet, we place a load balancer in between. And all overwhelming traffic can be sent to load balancer instead of server. The load balancer will distribute the traffic evenly across all servers. Here's a caveat though. You need to make sure that you have at least the same or more number of servers already available. If these servers too are unable to handle all the traffic, then the website will fail again. So you might want to have the maximum number of servers possible behind the load balancer. This is where auto scaling plays a very vital role. Load balancer always runs hand in hand with auto scaling, which is our next topic of discussion. Let's keep the same scenario. Load balancer itself can be a device or a software like Apache or Nginx running on single or multiple servers. If traffic increase, how can we be sure that the load balancer itself can handle the load? What I mean by that is, will the load balancer server or device have enough capacity to handle such huge spike in traffic? It can distribute traffic only if it works. That's why AWS provides elastic load balancer. Elastic load balancer scales the load balancer itself as necessary to handle the load. So here we place elastic load balancer, which takes the load of all incoming traffic. Incoming traffic is distributed across EC2 instances in multiple AZs. Instead of normal servers, we have EC2 instances in AWS. Load balancer is a single point of contact for clients. That means end user applications or internet users will never see EC2 instances. They'll communicate only with the load balancers. There are three types of load balancers: classic, application, and network load balancer. Before going further into elastic load balancer, I want to discuss a little bit on encryption. Encryption level 0. Level 0 because I will not discuss any concepts pertaining to encryption. This slide is just to give you an idea how encryption works. We will discuss encryption in length during KMS topic. We touch based on it a little bit in our VPC session. This is your machine and a server you want to communicate to. The communication travels over the internet, which is accessible to everyone and anyone. All data that we send are in plain text. If a bad guy wants, he can peek in and download all data which we do not want. In this scenario, we'll talk about two components of encryption. First component is the encryption of data during transfer. All data sent from this computer to the server will be encrypted during its journey. Even if the bad guy downloads this data, it will not make any sense to him as the data is encrypted. We already know this. I'm not going to tell you how encryption occurs or its logic, not to complicate things further. The second component is, how do you know the server that you are talking to is real? What if instead of the bad guy himself, a bad server is put in place or put in front of the actual server which looks exactly similar to the actual one? We think that this is the server we are meant to communicate, and we keep on sending out data. This time, bad guy downloads data from this server rather than from internet. There should be a way for us to know that the server we are talking to is actually the one it says who it is. SSL certificates tell us that this is the actual server which you want to talk to. The certificate is attached to the server. The certificates are provided by authorities who validate the authenticity of the servers and the organization hosting it. It is similar to a situation like, suppose you want to send some information to a person, but you do not know that person. You ask your friend who knows him or her. Once your friend approves of it, you are sure that you are sending the required information to the correct person indeed. Certificate authorities do that for us for servers. Classic load balancer. It distributes incoming application traffic across EC2 instances in multiple AZs. Routes traffic to healthy instances only. If any instance is down or not working, then classic load balancer will not send any traffic to that instance. It has both internet and internal facing load balancer. Internet facing load balancer is for use of the entire world. Internal load balancer works within the VPC. This is our VPC with two AZs. Each AZ is having one subnet and EC2 instances behind it. Here's our load balancer. If it receives any traffic, then all this traffic will be distributed evenly across multiple EC2 instances in both the AZs. Architecture of load balancer, how things are laid out. Whenever a load balancer is created, it launches a load balancer node, which is nothing but a host with load balancer installed in it. The elasticity that I was talking about is because whenever traffic increases, ELB creates new nodes with load balancer in it. These nodes should be in public subnet. Here we have two AZs, one A and one B. Each AZ has a private subnet. EC2 instances are placed behind these subnets. We want load balancer to send traffic to these EC2 instances only, which are in a private subnet. There are two public subnets in each of the AZs as well. When a load balancer is created, make sure to add these public subnets in the load balancer. That means load balancer should be created in a public subnet in the same AZ as that of the EC2 instances. As here EC2 instances are in AZ 1A and 1B, so load balancers should be placed behind public subnets in AZ 1A and 1B only. Each load balancer node will send traffic to EC2 instances in the same AZ only. You can see how many nodes are there for this load balancer using nslookup command. Let's see a demo, a very basic one. We'll spin up 4 EC2 instances in 2 subnets on different AZs. We'll install basic HTTPD or Apache service on each of these instances. We'll register the instances in classic load balancer and we'll use CLB DNS name to connect to the web servers. We'll see the distribution how it works.